Welcome to the lecture on dividing monomials. We want to talk about properties of exponents when you divide common bases. So you'll notice it says in blue, x to the m divided by x to the n is x to the m minus n. Now, I want to talk about where that comes from. So let's look at an example where we have a fixed value for m and n. So let's look at x to the 7th divided by x to the 4th. Without using that property, y'all know that x to the 7th is x times x times x times x times x. I could have picked a smaller number, couldn't I? Times x. So 1, 2, 3, 4, 5, 6, 7 of those x's all multiplied together, divided by x to the 4th, which is 4. So 1, 2, 3, 4 x's multiplied together. Now, you know when you have a fraction, you can simplify by dividing. So these 4 x's divide by these 4 x's to leave you 1. 1 times these 3 x's is x to the 3rd. So essentially that's why that happens. So instead of writing all these out and multiplying, you can simply subtract exponents. Okay, so let's look at a few examples down here. If I have x to the 14th divided by x to the 6th, that would be x to the 14 minus 6, which would result in x to the 8th. If I have 5 to the 10th divided by 5 to the 8th, again, what you're looking for is that you have a common base. These are both 5s. If these were different numbers or different variables, of course you couldn't apply this rule. So 5 to the 10 subtract 8 is 5 to the 2nd power. And that would be an exponential form. We all know 5 to the 2nd is 5 times 5, which is 25, and that would be simplified form. Now look at this. This is a little different right here. If you have x to the 6th over x to the 14th, if I do x to the 6th minus 14, that gives me a negative number. So what I want you to think about here, I'm going to use a different color here, is you need a rule that's going to be bigger exponent minus the smaller exponent, and the answer is where the larger is. Okay, so what I mean by that is this is going to be x to the 14 minus 6, yet 14, the bigger exponent, is in the denominator. So we need to think about this as 1 over x to the 14 minus 6, minus there, equals 1 over x to the 8th. Okay, now that doesn't show up in this property. This is only when, I should say, when m is bigger than n. So if m or n in the denominator is bigger than m, it's going to be 1 over. So we could create the rule that if n is bigger than m, it's going to be 1 over x to the n minus m. Did you catch that? So basically, bigger minus smaller, leave it where the bigger one is. And the case holds here, for example, D as well. Since 30 is bigger than 20, I'm going to say this is 1 over 8 to the 30 minus 20, which is 1 over 8 to the 10th. So let's look at a few more examples where we use this rule. So again, this rule in blue applies if m is bigger than n. On the other hand, if n is bigger than m, you would have 1 over x to the n minus m. Okay, so look, we've got both b's here. The numerator exponent is bigger than the denominator exponent, so we can say this is b to the 6 minus 5, which is b to the 1st, which we know is just b, because that's an implied 1 exponent. Now look at f. Slightly more complicated because you have coefficients here as well. So think about reducing these as you would always reduce a fraction. 5 divides into both 25 and 5, so I can say 5 goes into 5 one time. 5 divides into 25 5 times. And now let's look at the variable part. We have an x to the 11 over x to the 4th. The numerator is larger, so I'm going to say 11 subtract 4. So that's going to be x to the, we can go ahead and do this, right, 7th. Now this 1 in front, we don't have to have that. It's a coefficient. It's an implied 1 in front of the x anyway. So 1 times x to the 7th simplified is just x to the 7th over 5. And that expression is completely simplified. Now let's look again. This time we have three different types of factors. We have a constant, negative 32, constant multiple, and an x and a z. So let's think about these things one at a time. Negative 32 over 8. I can divide both negative 32 and 8 by 8. So you know negative 32 divided by 8 is negative 4. 8 divided by 8 is 1. Now let's look at the x's. Notice there's an implied 1 up here as the exponent for this x, and there's a 6 in the denominator for the exponent. So you know what I have to do? I have to subtract, but this time the larger of the exponents is in the denominator. So 6 subtract 1 is 5, but that x to the 5th goes in the denominator. Now when I look at z's, I have a 10th power and a 5th power. The bigger one is in the numerator, so I can say z to the 10 subtract 5 is z to the 5th in the numerator. Now the best way to write these answers, a couple of things I want you to look at. In the denominator, 1 times x to the 5th is simply x to the 5th. In the numerator, let's talk about negatives. Negatives are appropriate to me to put in the numerator or in front of the fraction, as long as your fraction is completely simplified. So a negative, let's just put that in the front, and 4z to the 5th in the numerator, and that's equivalent to saying negative 4z to the 5th on top. Now if the negative is in the denominator, which is not in this case, and you have a positive in the numerator, you know a positive divided by a negative is a negative, that would go out front as well, but you don't want to leave a negative just in the denominator. Okay, in the numerator is okay, but it really is better if you go ahead and simplify your negatives inside the fraction and bring it out front if it's negative. If it's positive, of course, it won't be there at all. Now look at this, 8 to the 20 divided by 8 to the 20. A couple of ways we can think about that, right? If I use my subtraction property, that's a to the 0. But on the other hand, we know that if you have the same factors in the numerator and denominator, they just cancel and they leave you with 1. So a to the 0, is it a to the 0 or is it 1? Well, actually it's 1. And on the next page we're going to get that formal definition that a base to the 0 power, as long as that base is not 0, is equal to 1. And here's that definition that I was talking about. It's called a zero exponent definition. E to the 0 is always equal to 1. And the last example that we just did shows that that's true. If you think about another example, if I give you, say, x to the 5th over x to the 5th. Now that compares to saying 2 over 2. Now we all know 2 divided by 2 is 1. So x to the 5th divided by x to the 5th also should be 1. But if we use our properties of exponents, that would be x to the 5 minus 5, which is x to the 0. And that's why we have to define that to be 1, because that's, you know, how our properties of exponents work. When you divide, you subtract. So as we simplify here, b to the 4th divided by b to the 4th is b to the 0, which is 1, or you can simply cancel those out to get 1. On the next problem, I have a fraction here I've got to deal with. 14 divided by 7 is 2. And you can say 2 over 1 or just 2, and x to the 4th and x to the 4th, they either cancel to leave you with just 2, or you can say that's x to the 0, and that would be 2 times 1, which is still 2. So there's two different ways to think about it, but you get the same correct result. Now I'm going to take a look here. I've got 3 different factors to deal with. I have a constant multiple factor, I have an x factor, and I have a z to the 10th in the top and z to the 12th in the bottom. So first let's look at the fraction part of this. I see that 9 divides into both 81 and 18. So 9 goes into 81 9 times. That negative will remain. 9 divides into 18 twice. When I look at my x's, I can think about that as x to the 0, which is 1, or I can simply just cancel them out. It's like dividing x divided by x is 1. Now z's, I have a z to the 10th and a z to the 12th. Remember, bigger exponent, subtract smaller exponent, and leave it where the bigger exponent is, so z squared is in the denominator. Now once again, we have this negative in the numerator issue. A negative divided by a positive is overall a negative. And then I have 9 over 2z to the 2nd. That's my official completely simplified example. Now look at this super complicated looking expression down here at the end. Notice that entire thing is raised to the 0 power. So we could work on simplifying inside here, but listen, since all of that is raised to the 0, that is just equal to 1. No matter if we simplify the inside or not of those parentheses, that is equal to 1 because the whole thing is to the 0 power. Notice something else. Notice this says A cannot be 0. So like 0 to the 0 is what we call an indeterminate form. It's not something that we are going to worry about in a Math 100 class. You get to visit that later on in your math career. Now I've got a new definition or a new property for you. We see that A over B to the M is A to the M power divided by B to the M power, as long as your denominator B is not equal to 0. This is true. Let's talk about why this is true. Let me give you an example. So if I give you, say, x over y to the third, by definition of an exponent, that's x divided by y times x divided by y times x divided by y. Well, multiplying fractions, you multiply numerator times numerator, that's x times x times x, which is x to the third. And also y times y times y is y to the third. So instead of writing all that out, we can simply go from a fraction raised to an exponent. You just apply that exponent to each of your numerator and denominator. It makes life a little easier. So when you look at example n, this is going to be 4 squared over 7 squared, which is going to be 16/49. And that's completely simplified. Or the next example, I have negative 1 to the 5th divided by x to the 5th. Now when you take a negative and raise it to an odd exponent, you know the answer is negative. If you need to think about it, multiply negative 1 times negative 1 times negative 1 5 times. That is going to give you a negative 1 over x to the 5th. A better way to write that, remember we talked about those negatives, a negative divided by positive overall is a negative 1 over x to the 5th. Alright, now on example P, we get to use two different properties. We had a property in a couple of sections ago that says that if you have multiplication inside an exponent, that exponent applies to both. So that's going to be negative 2 to the 4th times x to the 4th. And now our new property says it also applies to division, y to the 4th. And then I simplify that expression. I'm going to come down here. Negative 2 to the 4th is negative 2 times negative 2 times negative 2 times negative 2, which is a positive 16. You know, a negative raised to an even power is always positive. X to the 4th divided by y to the 4th. That's completely simplified. My last expression, down here, we're going to apply several properties. This exponent of 5 will apply to the 22, the a to the 13th, the y to the 3rd, the 11, the a to the 20th, and the y to the 1st. So I'm going to write that down. I'm going to start writing a little smaller so I don't run out of space. So I have 22 to the 5th, a to the 13th to the 5th, and y to the 3rd to the 5th, divided by 11 to the 5th, parentheses not required, but I'm going to put them, a to the 20th to the 5th, and then y to the 1st to the 5th. Now I simplify this. 22 to the 5th is a pretty big number. Listen, let's rethink this, okay? Because notice what's inside could have been simplified. Now what I'm doing is not wrong, but it's making our lives a little bit more challenging, or at least this problem a little bit more challenging, because I'm going to have more to simplify at the end. So let's rethink this. If you have a fraction raised to an exponent, let's simplify the inside of that first. It's almost like using order of operations, right? If we simplify the inside of the parentheses first, then raise it to the 5th power, we'll have less work to deal with. Okay, so that mistake was worth making. I really wanted you to see that. What I'm doing is not wrong, but it's better to simplify the inside first. You could carry on with what you're doing and see if we get the same answer. I probably would have as well, except for the fact that I'm running out of space. So I simplify this fraction inside first and then raise it to the 5th. Now look, y'all know 22 divided by 11 is 2. That leaves a 1 in the bottom I'm not going to write. 8 to the 13th over 8 to the 20th. The bigger exponent is in the denominator, which means my a's are going to remain in the denominator. 20 minus 13 is 7, so a to the 7th is in the denominator. When I look at my y's, I have a y to the 3rd and a y to the 1st. The bigger one this time is in the numerator, so 3 minus 1 is 2, so y squared is in the numerator. Now look, doesn't that look so much easier? That leaves me with 2 to the 5th. I have y squared also to the 5th, and in the denominator, a to the 7th to the 5th. 2 to the 5th is 32. Remember, when you have a power to a power, you multiply. That's y to the 10th divided by a to the 35th when I multiply 7 times 5. That 32 is living a little high down here. I'm going to make him look a little bit better and wrap this page up by saying my final answer here is 32 y to the 10th a to the 35th power. So it's not wrong to go ahead and apply that exponent, but I think it's easier if you simplify inside your fraction first if necessary, and then raise it to that exponent. You'll have less work to deal with in the end. So let's continue with our examples. We're going to use our division property. But now look, I've got z to the 3rd to the 8th. Now what I cannot do is simplify this without handling this 3 or 3rd to the 8th first. Remember, you have a power to a power, you multiply. So that's z to the 24th divided by z to the 15th. And then we can use our quotient property of exponents, our division, and 24 subtract 15, the bigger one's in the numerator. 24 subtract 15 is 9, so I have z to the 9th, which is in the numerator. Alright, let's keep going. I have r to the 6th and r to the 4th, but that entire thing is raised to the 3rd. Now remember that problem we did a minute ago that we rearranged says let's simplify the inside first, and then it would be easier work. So since these are both r's, I'm going to say this is r to the 2nd. Remember, bigger minus smaller, leave it where the bigger one is, still to the 3rd, and then finally multiply, power to a power is r to the 6th. Now you wouldn't be wrong to say that's r to the 18th over r to the 12th, and then do 18 minus 12, still going to give you r to the 6th. So you're not wrong if you thought to do that first. It's just a little extra work that's not required. Okay, next example. We've got something, a fraction inside here that cannot be reduced. We don't have any common factors. So I'm going to apply this 4 to all 4 of these factors, both of them in the numerator and both of them in the denominator. So I have 3 to the 4th, and then I have x squared to the 4th in the numerator. In the denominator I have 7 to the 4th, and then I have y to the 1st to the 4th. I continue to simplify. Now 3 to the 4th is 3 times 3 times 3 times 3, which is 81. X squared to the 4th is x to the 8th. Multiply those exponents. 7 to the 4th, I'm going to bring out my trusty calculator, and I've got 2,401. And then y to the 1st to the 4th, 1 times 4 is 4, so that's just y to the 4th. Now here's what I know. I know 81 and 2,401 will not simplify, and that's because 3 and 7 don't have any common factors. If they would have, I would have simplified right here or even before we even distributed that 4 inside. So this is as good as that answer gets. So final problem on this page, let's go with pink. Alright, now look at this 2. Okay, now look, I have common factors. I have c's all over the place. But I can't start canceling anything until I handle this 3 to the 2nd power, this 4 to the 2nd power, and this 2 to the 7th power. So not only that, look, this 2 right here applies to this 2 as well. And that's a mistake a lot of students would make. So be real careful. This 2 has to be raised to the 2nd power. This c to the 3rd has to be raised to the 2nd power, and over here this c to the 4th is raised to the 2nd power. We could have gone ahead and simplified that. And in the denominator, the c to the 2nd, look, let's go ahead and multiply 2 times 7 is 14. So that's c to the 14th down there. We keep going. 2 squared we know is 4. To the 3rd squared is c to the 6th. to the 4th squared is c to the 8th, and then we still have a c to the 14th in the denominator. Now remember, we haven't done this in a few problems. C to the 6th times c to the 8th. You add those exponents, so 6 plus 8 is 14. So I have 4c to the 14th divided by c to the 14th. Now if you're in the habit of using rules, 14 minus 14 is c to the 0, which by definition is 1, or I could say, hey, this cancels with this, and overall my answer is 4. So up here, that's a really complicated looking 4, but that's all that is. All right, for our last page of examples. So we'll have a lot of rules to use here. All of our rules involving exponents will probably come into play. I'm looking at negative 48 in the numerator, positive 8 in the denominator, so I'm going to write my fraction bar and simplify negative 48 over 8, which are both divisible by 8. Negative 48 divided by 8 is negative 6. 8 divided by 8 is 1. That 1 may not stay. Now look at my a values. I have an a to the 7th and an a to the 13th. Remember, rule is bigger minus smaller. Leave the base where the bigger one is. So the bigger's in the denominator. 13 minus 7 is 6. So a to the 6th goes in the denominator. B to the 4th and b to the 4th cancel. Or you think about that as b to the 0, which is just 1. Now this is not looking great. I need to make it look a little better. First of all, a negative divided by a positive is overall a negative. And here's my fraction bar. A 6 still remains in the numerator. 1 times anything is just that thing. So this is completely simplified. Let's change colors and move on to the next example. So I have a fraction going on here. I have a negative 63 divided by 9. 63 is divisible by 9. So I can say 9 goes into 63 and negative 7 times. 9 goes into 9 once. I look at my fraction here, or my x factor, x to the 8th over x to the 12th. The bigger one is in the denominator, so 12 minus 8 is x to the 4th. Y to the 3rd over y squared. Okay, so I have a 3 and a 2, bigger ones on top, so my answer remains on top. That's y to the 1st. 3 minus 2 is 1. Again, want to make this look a little better. A negative divided by positive overall is a negative answer. 7 divided by 1, you could say it that way, or you could just look at the numerator, and 7 times y to the 1st is just 7y. On the other hand, 1 times x to the 4th is x to the 4th. So that is the completely simplified answer. And then our last example for this lecture. Find a fancy color. There we go. Now, notice I don't have any exponents outside the parentheses, so I don't have to apply an exponent to every term inside the parentheses. What you may want to do, though, is go ahead and multiply this in the numerator. I have a negative 12 times the negative 4, which is going to give me a positive 48. I have an x to the 6th times an x to the 5th. Remember, when you multiply bases, you add the exponents. So you have to stop yourself and remind yourself of these rules. That's x to the 11th. Y to the 9th times y to the 8th. It's going to be y to the 17th. I'm again adding. 9 plus 8 is 17. I'm going to recopy what we have in the denominator. That's negative 12. X to the 10th. Y to the 12th. Now let's look at this factor by factor. So I'm dividing here because I have a fraction. Positive 48 divided by negative 12. If you think about that, that's overall a negative answer. Let's just put that negative in front. Okay, so again, positive divided by negative is overall negative. 48 and 12 have a common factor of 12. So 12 goes into 48 4 times. 12 goes into 12 once. So again, 12 divides into 48 4 times, 12 divides into 12 once, so that leaves a 4 in the numerator and that 1 in the denominator. Let's take a look at our x's. Bigger exponent minus smaller exponent, leave it where the bigger one is, so 11 minus 10 is 1, that's x to the 1st because the bigger number was in the numerator. Y's. So common base of y, I have a 17 and a 12. Once again, the bigger one is in the numerator, which means my y goes in the numerator, and 17 minus 12 is 5. Now I can make this look a little better. Look, there's only a 1 remaining in the denominator, so that's not required. Every whole answer has a 1 in the denominator, so really, all I need to do is write -4. I don't have to write the 1 as the exponent here, y to the 5th, and that is the most simplified version of that answer. I hope this helps you using properties of exponents. Have a good day.